In the vastness of the universe, amidst a cosmos filled with mysteries, shines majestically the Milky Way, our mother galaxy. With its 100 billion stars, spirals, and stellar arms, it enchants and intrigues since time immemorial. Delving into its secrets is an invitation to cosmic adventure, where science blends with fascination. Below, I present 100 facts about this imposing galaxy. The age of the Milky Way is almost as old as the universe itself, at 13.6 billion years. This long existence offers a glimpse into its rich history and cosmic evolution over time. The name Milky Way originates from Latin and means milky path, due to its milky appearance in the night sky, capturing the imagination of ancient peoples who contemplated its beauty. Our position in the Milky Way is about 27,000 light-years from its galactic center, a distance that keeps us in a privileged location to study its structure and composition. The galaxy features four main arms: the Orion arm, the Sagittarius arm, the Perseus arm, and the Cygnus arm, each teeming with stars, nebulae, and other fascinating celestial objects. One of the most impressive events awaiting the Milky Way is its future collision with the Andromeda Galaxy, predicted to occur billions of years from now, transforming the cosmic landscape spectacularly. With an impressive diameter of about 100,000 light-years, the Milky Way stretches over vast distances in space, housing billions of stars and numerous cosmic mysteries. The total mass of the Milky Way is estimated to be approximately 1.5 trillion solar masses, a measure reflecting the vastness and gravity of our galaxy. The stellar expanse of the Milky Way is evidenced by the presence of between 100 to 400 billion stars, each contributing to the richness and diversity of the galactic cosmos. In its journey around the galactic center, the Sun takes about 230 million years to complete one orbit, witnessing countless cosmic eras along its trajectory. As we approach the galactic nucleus, the stellar density in the Milky Way significantly increases, creating a dense and dynamic stellar environment. The vast majority of stars in the Milky Way are in the phase known as the main sequence, including our own Sun, which shines as one of the many common stars in the galaxy. At the heart of the Milky Way lies a supermassive black hole, known as Sagittarius A*, whose colossal mass exerts a dominant influence over the stars and the surrounding environment. One notable feature of the Milky Way is the difference in orbital velocity of stars, with those closer to the galactic center orbiting more rapidly than those in the periphery. Active regions of star formation, known as stellar nurseries, dot the Milky Way, revealing the dynamic processes that shape the galaxy over millions of years. In addition to its stars, the Milky Way harbors vast amounts of interstellar gas and dust, crucial materials for the formation of new stars and planetary systems throughout the galaxy. The center of the Milky Way is filled with cosmic gas and dust, forming an intense region of stellar activity and offering intriguing glimpses of galactic formation processes. Traveling at a speed of about 828,000 kilometers per hour, the rotation of the Milky Way creates a celestial spectacle in constant motion, fueling the curiosity and study of astronomers. The distance between the Sun and the center of the Milky Way is about 25,000 light-years, a measure that puts our position into perspective within the cosmic vastness of the galaxy. As part of the local group, which includes the Andromeda Galaxy and other nearby galaxies, the Milky Way is immersed in a vibrant and dynamic intergalactic universe. Beyond the visible stars, the galaxy is punctuated by a myriad of planets, estimated in numbers between 100 and 400 billion, offering a glimpse of the planetary diversity that may exist throughout the cosmos. The cosmic history of the Milky Way is marked by several mergers with smaller galaxies over billions of years, events that shaped its structure and contributed to its stellar richness. With a galactic disk with an average thickness of about 1,000 light-years, the Milky Way exhibits an impressive structure that reveals its cosmic complexity and beauty. Our location in the Milky Way, in the Orion arm, offers a unique perspective of the stars and nebulae that populate our corner of the galaxy, inspiring continuous exploration and discovery. The variety of stellar colors in the Milky Way reflects the diversity of stars, with hues ranging from red to blue, indicating differences in temperature, age, and chemical composition. The presence of dark matter in the Milky Way is an intriguing feature, with dark mass far exceeding the visible mass of stars and gas, challenging our current understanding of matter in the universe. Globular clusters are prominent features of the Milky Way, spherical groupings of ancient stars orbiting the galactic nucleus, providing glimpses into the stellar history of the galaxy. Continuous gravitational interaction with other galaxies, such as the Andromeda Galaxy, influences the motion and evolution of the Milky Way over cosmic time, shaping its structure and dynamics. Dwarf galaxies orbit the Milky Way as satellites, contributing to the complexity and diversity of the galactic environment and offering clues to the formation and evolution of the galaxy. Streams of stars traverse the Milky Way, remnants of dwarf galaxies that were torn apart by the galaxy's gravity, creating a cosmic tapestry of stellar motion. The rotational motion of the Milky Way influences the distribution and behavior of stars, creating complex patterns of orbital movement throughout the galaxy. The Smith Cloud is a vast cloud of cold, dense gas stretching for thousands of light-years in the Milky Way, providing material for the formation of new stars and planetary systems. The history of the Milky Way is marked by episodes of intense star formation activity, with active regions of stellar nurseries scattered throughout the galaxy. The presence of dark matter in the Milky Way challenges scientists to better understand the nature of matter in the universe, paving the way for new theories and discoveries. The galactic disk of the Milky Way is traversed by streams of cosmic gas and dust, creating a dynamic and ever-changing cosmic landscape. The orbital motion of stars in the Milky Way is influenced by gravitational interaction with other nearby galaxies, creating complex patterns of stellar motion throughout the galaxy. The presence of globular clusters in the Milky Way provides important clues about the stellar history of the galaxy and its process of formation and evolution over cosmic time. The Milky Way continues to challenge our understanding of the universe, inspiring generations of scientists to explore its mysteries and unravel the secrets of its formation and evolution. Stellar diversity in the Milky Way is evident in its variety of colors, brightness, and sizes, reflecting the complexity and richness of the galactic environment. The total mass of stars in the Milky Way contributes to its immense gravity, which influences the movement and dynamics of all parts of the galaxy. The spiral structure of the Milky Way is a striking feature of the galaxy, revealing its dynamic and evolutionary nature over billions of years. The galactic nucleus of the Milky Way is a dense and luminous region, filled with stars, gas, and cosmic dust, offering an intriguing view of the processes occurring at the heart of the galaxy. The Milky Way continues to intrigue and fascinate astronomers and space enthusiasts, inspiring us to explore and discover the secrets of our mother galaxy. The presence of a mysterious, Great Fermi Bubble, at the center of the Milky Way, a huge structure of gamma-ray emission whose origin has not yet been fully understood. Observations indicate the existence of a cosmic railroad along the galactic plane, a series of moving star streams whose cause is still under investigation. Recent discoveries suggest the presence of a disk anomaly in the Milky Way, a region where stars and gas have peculiar and unpredictable movements, challenging conventional theories. Evidence points to the existence of inflection points in the stellar evolution of the Milky Way, moments when the rate of star formation and other galactic processes change drastically, but the causes remain unknown. X-ray observations have revealed the presence of X-ray bubbles in the Milky Way, regions of intense X-ray emission whose origin has not yet been fully explained. Studies indicate the existence of radial pulsations in Milky Way stars, periodic variations in their luminosity that defy the predictions of current stellar models. The discovery of hot hydrogen spots in the galactic disk suggests the presence of unknown processes or astrophysical phenomena not yet understood. The detection of high-velocity molecular clouds in the Milky Way raises questions about their origin and their role in the galaxy's dynamics. Observations have revealed the existence of microwave radiation arcs in the Milky Way, structures that challenge conventional explanations of energy distribution in the interstellar medium. The discovery of cold gas filaments among the stars of the Milky Way suggests the presence of star formation processes not yet understood. Evidence indicates the existence of fossil stellar streams in the Milky Way, remnants of dwarf galaxies that were assimilated by the galaxy and whose properties defy theories of galactic merger. The presence of main-sequence blue stars in unexpected regions of the Milky Way suggests unusual or unknown star formation processes. The detection of supersonic shock waves in molecular clouds of the Milky Way points to the presence of cataclysmic events or unidentified sources of energy. Recent observations suggest the presence of plasmoid bubbles in the Milky Way's magnetosphere, phenomena that challenge existing theories of interaction between magnetic fields and plasma. Studies indicate the existence of antimatter bubbles in the central region of the Milky Way, whose origin and nature are still debated among scientists. The discovery of exotic binary stars in the Milky Way, with unusual or unexpected characteristics, challenges our current understanding of the formation and evolution of stellar systems. X-ray observations have revealed the presence of relativistic jets in compact binary systems of the Milky Way, phenomena that defy conventional theories of high-energy physics. The detection of gamma-ray flares in the galactic center region suggests the presence of extremely high-energy sources yet to be identified. Studies indicate the presence of ring structures around star clusters in the Milky Way, whose origin and astrophysical significance have not yet been fully understood. The discovery of gravitational wave echoes in the distribution of stars in the Milky Way suggests cataclysmic cosmic events or high-energy astrophysical phenomena occurring on galactic scales. The increase in detection of potentially hazardous asteroids in the region near Earth's orbit, originating from the Milky Way's asteroid belt, has raised concerns among scientists about the possibility of catastrophic impacts. Observations of a possible increase in seismic activity in Sun-like stars in the Milky Way raise questions about the stability of intermediate-mass stars, including our own Sun, and their potential impact on planetary systems. The discovery of a possible rapidly changing galactic magnetic field in the Milky Way raises concerns about the unpredictable effects it may have on star formation regions, as well as the stability of planets and stellar systems. The detection of supermassive black holes in unstable orbits at the center of the Milky Way raises concerns about the possibility of catastrophic interactions with nearby stars and the potential release of high-energy radiation jets. The identification of a possible supernova near the solar system in the Milky Way raises concerns among scientists about the harmful effects of cosmic radiation and resulting interstellar debris on neighboring planets and stellar systems. Recent observations suggest an increase in cosmic ray activity in the central region of the Milky Way, raising concerns about the harmful effects of this radiation on astronauts and space equipment during future galactic exploration missions. The detection of possible emissions of gamma rays of unknown origin in the outer region of the Milky Way raises concerns about the presence of potentially hazardous astrophysical sources, such as gamma-ray bursts or collisions of neutron stars, in the vicinity of the solar system. Now I will detail some of the most well-known solar systems in our Milky Way galaxy. Information about some notable solar systems in the Milky Way. Solar System, Sun. Composed of 8 major planets, including Earth, and a variety of other celestial bodies, the Solar System is our home, located on the outskirts of the Milky Way. Curiosity. The Solar System formed about 4.6 billion years ago from a collapsing cloud of gas and dust, with the Sun forming at the center and the planets condensing from the protoplanetary disk around it. TRAPPIST-1 system. Located about 39 light-years from Earth, the TRAPPIST-1 system is known to harbor 7 Earth-sized planets, 3 of which are in the habitable zone, where liquid water could exist on their surfaces. Curiosity. This planetary system is one of the prime candidates for the search for extraterrestrial life within the Milky Way, due to its proximity to us and the presence of potentially habitable planets. Alpha Centauri system. Alpha Centauri is the closest stellar system to the Solar System, located about 4.37 light-years away. It is composed of 3 stars, Alpha Centauri A, Alpha Centauri B, and Proxima Centauri. Curiosity. Proxima Centauri hosts a planet known as Proxima Centauri b, which orbits in the habitable zone of the star and is one of the main targets in the search for extraterrestrial life. Kepler-90 system. Located about 2,545 light-years from Earth, the Kepler-90 system is notable for having the same number of planets as our own solar system, 8 in total. Curiosity. This system was discovered using the Kepler Space Telescope and is an example of how other planetary systems may be similar to our own. What did you think of our video today? Don't leave the video without commenting the phrase, "I made it to the end." It helps me know if our content is enjoyable and where we can improve. Subscribe to our channel and leave a big like on this video if you enjoyed it. See you on our next journey. Also, watch other videos on